I'm Anil Kumar, and in this video I'll take a few examples based on what we have learned in part 1 and 2 of trigonometric ratios. Now we'll take few word problems like I'm showing you here and some straightforward questions. However, the common thing will be that we'll not use any calculator and we'll try to use the special triangles to solve these questions, right? So I'll begin with this question here, which is solve the triangle if sine alpha equals to half, and that is the triangle given to us. Now in this particular question, when we say solve the triangle, that means find all sides and find all angles. So whenever we say solve the triangle, this is what we mean. I hope that point is very clear. Now, since one angle is given to us as 45, we'll also use a special triangle with 45 degrees. So just reminding you of that. If this is 45, that means we have two equal sides, correct? So we'll take those sides as 1 unit long. So we'll say these sides are 1, 1, and the hypotenuse is square root 2. Since we know this is 45 degrees, and that is 90 degrees, this has to be 45. So these two are equal. Isosceles triangle. Sides opposite should also be equal. Therefore, AD should be 14. Right? So straight away, from my special triangle, I get an idea that the two sides have to be equal, right? So that gives us AD equals to 14 units, right? Now, we are given sine alpha as half. What does that mean? Sine alpha equals to half. Now, sine is a ratio of opposite side to hypotenuse. So if you look from alpha, then the opposite side is 14, correct? So what we know here is that opposite side is 14, but hypotenuse is BC. This is the hypotenuse, correct? For this particular triangle. So hypotenuse is BC. Now that simply means that we have a ratio which is half is equal to 14 over BC. All these are called trigonometric ratios, right? They are ratio of the sides. So I hope this point is well taken care of. So from here, if you cross multiply, you get BC as equals to 2 times 14, which is 28, correct? So we get hypotenuse, this hypotenuse as 28. Correct? Now, how do I get CD? This is indeed slightly difficult. So now we'll take help of another triangle, which is our 60, 30, 90 triangle. Is it okay? So this is 60 degrees, that is 90 degrees, and here we have 30 degrees. The ratio of the sides, as you know, are 1, 2 and square root 3. 1, 2 and square root 3. So that is the ratio of the sides. If I say sine alpha is half, let me just circle this in green. If I say sine alpha is half, that means opposite to hypotenuse is half. So opposite to hypotenuse is half for 30 degrees. This is the opposite side, that's the hypotenuse. So that means alpha is equals to 30 degrees. Does it make sense to you? So by comparing alpha equals to 30 degrees, since sine of 30 degrees is half, which is given. Does it make sense to you? So now we find that alpha is 30 degrees. So this angle is 30 degrees. Obviously, that should be 60 degrees now. So we have a 30, 60, 90 triangle right there. the sides ratio should be what? So now we know that is how the triangle is. So if you look from the sides, CD is opposite to 60 degrees, 30 degrees, hypotenuse. So what we see here is that the ratio of the side should be, let's write, 14 is to 28, right? Is to this side CD we don't know should be equal to what? 14 is 1 is to 2, 1 is to 2 is to, and this is square root 3. That is the kind of ratio, correct? That is the kind of ratio. So that means to get to the result, what are we going to do? We are just going to multiply each term by 14 to get the result, correct? So that is possible only if I multiply each term by 14. I get 14 is to 28 is to 14 square root 3. So that means CD is equals to 14 square root 3. Does it make sense? So this is 14 square root 3. So with that, I think we have solved the triangle. We got all the angles, right? Now angle B is 45. So the last thing we could do is find angle B, that is angle ABC, which is angle ABD plus angle DBC, which is 45 degrees plus 60 degrees. Does make sense to you? So it is 45 plus 60, which is 105 degrees. So angle B is 105 degrees, correct? So we get all our solutions here. I hope that is straightforward and simple. However, you have to juggle between these triangles and your understanding of trigonometric ratios to solve such questions. So we got our answers, angles as 45 degrees, angle B is sum of 45 and 60, which is 105. Alpha here is 30 degrees, since sine alpha is half. So we got the hypotenuse BC as 28, AD as 14, DC as 14 square root 3 DC. And if you add them up, A to C, it'll be 14 plus 14 square root 3. Right? So that is how you could solve it. Now let's take up some word problems. Thank you. I'm Anil Kumar. This is an extension to my review on trigonometric functions part 1. So we've taken up practice questions from previous test papers so that you can apply the learnings from part 1 and 2 of the review or summary of trigonometry. All this has to be done without calculator. This question is an application of splintered tree. The question is, a tree is splintered by lightning 2 meters up its trunk so that the top part of the tree touches the ground. The angle the top of the tree forms with the ground is 60 degrees. Before it was splintered, how tall was the tree? So that's the question for you. So you can always pause the video, answer the question. Here is kind of the diagram which we could make. So let us assume that initially the tree was kind of like this. Now because of the lightning, it broke off from here and came down, making an angle of 60 degrees. Do you see that part? And this portion from where it broke was 2 meters high. So basically, initially this was right there, correct? Let's say here. So the total height is h, which we need to find, right? So total height here is h, so which we need to find. So if this is unknown x, then that should be equal to this x. So we know from here that the height of the tree is the initial height. will be equals to 2 meters plus x. Now when it falls, it makes an angle of 60 degrees, and we'll assume that tree is at right angles to the ground. That is an assumption. Now what do we need to find? We are given a triangle where we need to find the hypotenuse. We know the opposite side, right? Now from what we learned, SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Since we are working with opposite and hypotenuse, right, opposite to 60 degrees, we should use sine. So that gives us that sine of 60 degrees is equal to opposite side of 2 meters divided by x. Now from here, we can write what x is. We can say x is equal to 2 divided by sine of 60 degrees. So just cross multiply. Now how do we know what is sine of 60 degrees? Well, let's look into our special triangle. So we are going to use this special triangle to evaluate what sine 60 is. So in a special triangle, that angle is 60 degrees. The sides are 1, 2 and square root of 3. So clearly sine 60 is square root 3 over 2, right? So we know that sine 60 is square root 3 over 2. Opposite side over hypotenuse. So we could write this as square root 3 over 2, and that gives you the value of x as equal to 4, this 2 goes in the numerator, over square root 3. Do you see that? So we get the value of x. Once we know x, we can always find the original height. So original height is equal to 2 meters plus x, which is 2 plus 4 over square root 3. So you can just take common denominator. So you get 2 square root 3 plus 4 over square root 3, right? Now at times you may be required to rationalize this, multiplying and dividing by square root 3 and get an answer without a radical sign. So that could be also an extension. So just multiply and divide by square root 3 to rationalize. In that case, what you get here is, let me rewrite, that becomes 3 times 2, 6 plus 4 square root 3 over 3. Do you see that? Now it could be written as 3 plus 6 is 2 plus 4 over 3 square root 3. Do you see that? So at times you could rationalize this. 4 over 3 square root 3 meters is your original height, correct? So that is the way such problems could be done. So we could do it at this stage also. We could write this as 4 square root 3 over 3, and then adding to 2 we get our height. So this is 4 square root 3 over 3. Okay. So I hope these steps are absolutely clear. We'll take a few more examples based on trigonometric ratios. Now let us take up an example to find height of a building. The equation here is, from a window of one building, Anil finds the angle of elevation of the top of second building is 45 degrees. An angle of depression of the bottom is 60 degrees. The buildings are 50 meters apart. Find the height of second building. The idea of having this question is to understand what is angle of depression and what is angle of elevation, plus also how to use the trigonometric ratios which we have just learned in this particular part A and part 1 and part 2 of summary of trigonometry. Now in this example, let us make a diagram. Let's say this is one building and the other building is, let us say, kind of here. So these are the two buildings. Let's call them A and B as their top. Distance between these two buildings is 50 meters. When we say angle of elevation, it means what? it has to be measured from horizontal. So if I connect a line to the top of the buildings from A to B, I get an angle of elevation which is this. So looking from A upwards with the horizontal, so it says top of the second building is 45 degrees. That is the angle of elevation. So this angle is 45 degrees. And the angle of depression of the building is 60 degrees. Angle of depression is when you're looking downwards, and it is also measured from the horizontal. So let me connect these 2 points. And that angle is the angle of depression, which is 60 degrees. You get an idea. So this is your 60 degrees angle of depression. It's going downwards. Both are measured with horizontal. This is very important to understand. And of course, that is right angles. We need to find height of the second building. That means this height. Let's call this point as O. Then we are interested in finding total height. Let's call this height as capital H. Now clearly this height could be a combination of, let's say this is a point C here. There's a combination of BC and CO. We have 2 triangles. We can solve both these triangles and find the height. So I'm going to use tangent ratios, tan ratios or tangent ratios. Okay, so what is tan? So tan of an angle theta is opposite side over adjacent side, correct? Now that is one thing. Second, these are the 2 triangles which remind you of special triangles, 45 degrees and the 60 degrees ones. Let me sketch these triangles also here. Their side lengths are, these 2 sides are equal, 1 square root 2 for 45 degrees. And for a 30, 60, 90 triangle, the sides are, if this side is 60 degrees, 1, 2 and square root 3. Using special triangles, we can easily get all our sides. So 45 degrees really means that these 2 sides are equal. A to C is 50, correct? Since that is the distance between the 2 buildings, this is 50. So that side should also be 50, perfect, in meters. Now if you look into the other triangle, we have 30, 60, 90, correct? If this is 90, 60, that has to be 30. So it is this triangle. The ratio is 1, 2 and square root 3. So the hypotenuse is twice this. You can write 100 here. And this side will be square root 3 times the adjacent side. So this side is square root 3 times 50. Do you see that? And total height should be sum of these 2. That is the solution. You get the idea. So using our special triangles and the knowledge, we have the answer height h equals to 50 plus 50 square root 3 in meters. Do you get an idea, right? So that is how you can see your solution. Now let me do it in a way which is more meaningful for most students. So we'll work with this, and we say tan of 45 degrees is equal to 1, and this is also equal to, from this, opposite over adjacent. So in triangle ABC, we are considering the triangle in triangle ABC, right? We're considering this triangle. Opposite side is BC divided by adjacent is AC, and we know AC is 50. So I could write this as BC over 50, and by cross multiplying, I know BC is equals to 50. Got it? So we get one side 50, which we had already worked out earlier. Similarly, now let's look into the triangle ACO. In this triangle, again, we'll look into the tan ratio. So we have tan of angle 60 degrees equals to, opposite side is CO divided by AC. CO we need to find, let's keep it like this. AC is given to us as 50. And what is tan 60? Tan 60 is square root 3. So this should be square root 3. So with cross multiplication, we get CO equals to 50 times square root 3. Is that clear to you? So for the second triangle, we get CO as 50 times square root 3. So height of second building is how much? Sum of these two, that is BC plus CO, which is 50 plus 50 times square root 3. If you want, you can take them common. 1 plus square root 3, and the units are in meters. Correct? So that is how you could solve it algebraically also. So I provided you with a quick solution and a detailed solution. I hope that helps. I hope with this you get good hold on understanding of trigonometric ratios and applying them to solve some real life situations. Thank you and all the best.